One of the ways in which we can find the value of a limit is a situation in which we have a graph of the function in question. When we have a graph of the function, limits can usually be found easy by seeing what happens to the y-coordinate as the x-coordinate approaches a. We can find the limit by reading it off the graph. In the example of this graph here, we can find the limits. The limit as x goes to 0 of f of x, the limit as x goes to 1 of f of x, and the limit as x goes to negative 2 of f of x by looking at the graph and seeing what happens to the y-coordinate as the x-coordinate approaches each of these points. If we want to do the limit as x goes to 0 of f of x, we want to look at what happens to the y-coordinate for x-coordinates near 0. As x approaches 0, the y-coordinates are going to approach 2 here, which means that the limit as x goes to 0 of f of x is going to be 2. If x approaches 1, we can approach 1 either this way or this way, but as we approach 1 in either direction, both y-coordinates approach this point here, which is y-coordinate 1. So the limit as x goes to 1 of f of x is going to be 1. If you want to take the limit as x goes to negative 2 of f of x, we're going to approach the x value negative 2. We can approach it either this way or this way. Either way, we're approaching this point, which has y-coordinate 0. Remember, when we're reading a limit off a graph, that what x approaches, that's saying something about the x-coordinates. The thing we're going to be finding the limit of is saying something about the y-coordinates. So the answer to your question, the answer to the limit, the value of the limit is always going to be a y-coordinate, not an x-coordinate. One type of function where limits are particularly important are functions in which the graph has a hole in it. A hole in the graph is usually represented by an open circle. The open circle represents a point where the limit exists, where we can find the limit of the function, but the value of the function is either undefined or different from the limit. For example, in this graph shown, at this point here, the limit is going to approach this circle, but the value of the function is up at this circle. At this point, the limit's going to approach this open circle down here, but the value of the function is not defined at all. However, we can use this graph to find a number of limits. We can find the limit as x goes to 2 of g of x. If we want to approach the x-coordinate 2, we can approach it either this way or this way. Along the function, we're going to approach it either this way or this way. Either way, we're going to approach this point here, which has y-coordinate 1. If we want to take the limit as x goes to negative 1 of g of x, we're going to approach the x-coordinate negative 1. We can approach it either like this or like this. Either way, we approach this point, which has y-coordinate 1. If we want to take the limit as x goes to 0 of g of x, we want to approach the x-coordinate 0. We can approach it either this way or this way. Either way, we're approaching this point here, which has y-coordinate negative 1.